to 1.6 practice. As I said, word problems can be a little more challenging, so I will help you out with some of these practice problems if you need it. If you want to take on the challenge, of course, you should try these first. Try, and then seek out help afterwards. All right, so mixture problems. How many milliliters of 24% alcohol solution must be mixed with 6 milliliters of 78% alcohol solution to make 60%? So again, think of it as a balance. On the left, we're going to have 0.24 of some quantity plus 0.78 of 6 milliliters, and that's going to need to equal 0.60 of our new quantity plus 6. Okay, that right there is the setup. Okay, the first solution plus the second solution is equal to the new quantity. All right, so that's how you set it up. I'm going to let you finish the distributing and solving, and then you can check your answers formally on the worksheet. So that's the setup. I just want to go over the setup with you guys. Number 2, how many ounces of a metal containing 20% nickel must be combined with 6 ounces of pure nickel, okay, to form an alloy? So remember, if it's pure, that means it's 100%. All right, pure is 100% nickel in this case. So ounces of a metal containing 20% nickel. So 0.20 of some metal plus, okay, 1 times 6 ounces is equal to 50%, 0.50 times our new quantity plus the 6 ounces. Okay, that should get you in good shape for the next part. So ounces of a metal containing 20% nickel combined with 6 ounces of pure nickel, so 100% to go from there. Again, distribute, solve, and you should get the answer for that. How much brand of fruit punch A? Fruit punch B. So brand A fruit punch, 5%. So be careful. That's 0.05. Quantity we're not sure of. Plus 3 gallons of 50%. So 0.5 is 50, and we are adding 3 gallons of that. Now we need to make a mixture of 20%, which is our new quantity plus the original, and that's it there. So 0.5x plus 0.5 times 3 is equal to 0.20, and so forth. And last one, mixed nuts. Okay, so kilograms of mixed nuts containing 20% peanuts. So 0.2 of our peanuts plus 40% of 7 kilograms, and we need to equal that to 0.27, the original quantity plus our new quantity, and that's it there. So those ones, that is how you set up those. I'll leave the distributing and solving to you. All right, distance problems, setting these ones up. Diesel train made a trip to the repair yards and back. So again, the distance is the same, so we're looking to match out rate and time is equal to rate and time. On the trip there, it traveled 88 kilometers per hour. Okay, on the trip back, it went 16 kilometers per hour. How long did the trip there take if the return trip took 11 hours? Okay, so the rate, so this is going, and this is our return. So let's just consider going there, okay? We know that going there, it traveled 88 kilometers per hour. So 88 kilometers per hour. That's our rate, okay? And we don't know the time. So we're solving for the time. On the return, it went 16 kilometers per hour. So 16. And we know it took 11 hours. Remember that the distance is the same, so the times or the rates we can solve for. So in this first place, we just have 88t. Okay, ignore the units for this particular time. 16 times 11 is 176. Again, this time we have just hours. And when we divide, 176 divided by 88. Sure enough, so I solved this one the whole way through for you. We get a time is equal to 2 hours. Or kilometers per hour, sorry. Or 2 hours, yep. Okay, so that one, just setting up, solving for time. And again, if it's traveling the same distance, rate time is equal to rate times time. All right, so number 6 here, this is an exceptional challenge. It's not going to be something that will be on a test, but I just figured I would put it on here to challenge you, okay? Lots going on. So Scott left home traveling towards the lake 3 hours before Mike. Mike traveled in the opposite direction, going 30 miles per hour, faster than Scott, for 1 hour, after which time they were 155 miles apart. Okay, how fast did Scott travel? So what we have here is Mike's traveling, okay? So let's find out how far Mike has gone, and we know that's going to be equal to the distance apart they are minus Scott's speed and time. And this is Mike's speed and time. Okay, so Mike's travels. We know that Mike's speed is 30 miles per hour faster than Scott's. So Mike's speed is Scott's speed plus 30. And how long is he traveling? Or just traveling that for 1 hour. Okay, now that's equal to the distance apart they are. And now we have Scott's speed, which we don't know. And the curveball here, another one, is for how long has Scott been traveling? Well, he left before Mike 3 hours. So he went towards the lake 3 hours before. Now, this 155, however, is with the addition of 1 more hour. So Mike's been traveling his speed for 4 hours. Okay? And again, it's not tested, but just some little curveballs, some ways to make you think here for this course. Okay, so on the left here, we just have the speed and distributing, so that's just x plus 30 is equal to 155 minus 4x. What ends up happening is we'll subtract 30, so we get 125 is equal to, if we add 4x over 5x, and when we divide by 5, we get the speed of 25 miles per hour. Okay, so all that, just little tiny curveballs. Again, not tested. Maybe a bonus type question coming out there. But anyway, hopefully at least the mixture problems are a little easier, and the distance problems, they may challenge you, but that's part of life, guys. So good luck. Check your answers for the rest of those, and you'll do just fine.